In the vast, cold depths of space, farther than any other human-made object has ever reached, lies NASA's Voyager 1 spacecraft. Launched nearly 47 years ago, in 1977, this small, robust machine has defied the limits of human expectation. It has traveled well beyond what anyone imagined possible, venturing out of the protective bubble of our solar system and into the mysterious region known as interstellar space. Imagine, if you will, the idea of sending a spacecraft into the void nearly half a century ago, designed to last just a few years, and watching it still operate today, sending precious data back to Earth from billions of miles away. It's an extraordinary testament to human ingenuity and ambition. Voyager 1 is not just a relic of a past era. Though it is far beyond the planets and the asteroid belts that were once thought to be its ultimate goal, it continues to push the boundaries of exploration. What makes this spacecraft even more remarkable is the technology it carries, a technology so old, it predates the era of personal computers and is simpler than the cassette players many of us grew up with. Despite this, Voyager 1's instruments continue to function, transmitting data across the vast cosmic ocean to scientists eagerly awaiting its insights. The Voyager missions began during a unique window of opportunity in the late 1970s. Thanks to the brilliance of NASA's Jet Propulsion Laboratory scientist Gary Flandreau, a rare planetary alignment was discovered. This alignment of Jupiter, Saturn, Uranus, and Neptune, the four gas giants, occurs only once every 176 years and allows a spacecraft to use the gravitational pull of each planet to slingshot itself onward to the next target. This gravity assist significantly shortens the time needed to travel to these distant worlds. Without it, a journey to Neptune might have taken 30 years or more. With this trajectory, it was possible in just over a decade. Seizing this chance, NASA launched two identical spacecraft, Voyager 2 on August 20, 1977, and Voyager 1 just 16 days later on September 5, 1977. These twin explorers were tasked with an ambitious mission: to visit the outer planets, study their atmospheres, rings, moons, and magnetic fields, and then continue on toward the outer edges of the solar system and beyond. What happened next was nothing short of extraordinary. Both Voyagers sent back close-up images and data from Jupiter and Saturn that revolutionized our understanding of these massive planets and their diverse and complex systems. The discoveries were breathtaking: active volcanoes erupting on Jupiter's moon Io, vast ice fields on Europa, and intricate ring systems around Saturn that were far more detailed than ever imagined. The moons revealed themselves as dynamic worlds, each with unique geological activity and histories, transforming our view of the solar system from a static place to a vibrant and evolving environment. Voyager 2 continued its journey to Uranus in 1986 and Neptune in 1989. Becoming the first, and so far only, spacecraft to fly by these distant ice giants. The data and images returned astounded scientists, showing weather systems with supersonic winds, magnetic fields with strange orientations, and moons that bore evidence of ancient geological upheaval. These missions opened up entirely new fields of study and spurred decades of ongoing research into planetary science. Yet the real journey for these spacecraft began after their planetary encounters. Both Voyagers were set on paths leading out of the solar system, toward the distant boundary between our Sun's influence and the vast unknown of interstellar space. Voyager 1's trajectory took it above the plane of the planets, while Voyager 2 stayed closer to that plane, offering complementary perspectives of the outer reaches. As they left behind the planetary orbits, the spacecraft faced daunting challenges. The harsh environment of space is unforgiving, and the probes relied on onboard systems that today would seem primitive. Voyager's computers had just 69 kilobytes of memory, less than a modern text message, and were powered by a combination of reliability and sheer ingenuity in design. The instruments gathered data and stored it on magnetic tape recorders, which then transmitted information to Earth using radio signals sent via a 12-foot diameter dish antenna. These signals traveled at the speed of light, yet because of the vast distances involved, the messages took hours, sometimes nearly a day, to reach mission control. One of the greatest difficulties came with maintaining communication. As Voyager 1 moved farther away, its signals grew weaker and weaker, struggling to rise above the constant noise generated by human-made sources such as radios, televisions, and cell phones back on Earth. The Deep Space Network, a collection of giant antennas strategically located around the globe, worked tirelessly to catch every faint whisper from Voyager. The spacecraft's transmitter used only about 23 watts of power, roughly the same as a household light bulb, sending its messages across billions of kilometers of empty space. Despite these immense distances and technological limitations, Voyager continued to amaze. Scientists received data from regions of space never before explored, revealing details about the solar wind, magnetic fields, and cosmic radiation. These insights fundamentally changed our understanding of the solar system's boundary and the environment beyond. One of the most fascinating regions lies just beyond the heliopause, the boundary marking the edge of the Sun's solar wind bubble. Here, the solar wind slows down and eventually stops as it collides with the interstellar medium, the thin soup of gas, dust, and cosmic rays that fills the space between stars. Voyager 1 crossed this boundary on August 25, 2012, marking humanity's first step into interstellar space. This was a milestone moment, a leap into the unknown. The transition was not as sudden as scientists had predicted. Instead of an abrupt change in conditions, Voyager 1 detected a gradual increase in the density of plasma, the ionized gas that makes up much of interstellar space. Surprisingly, measurements showed little change in the direction of the magnetic field, which challenged existing theories about how the heliosphere interacts with the galactic environment. The Voyager mission team found themselves facing new puzzles, forcing a rethink of astrophysical models. Beyond the heliopause lies the mysterious Oort cloud, a distant spherical shell of icy objects and comets thought to surround the Sun at distances up to 100,000 astronomical units. An astronomical unit, or O, is the average distance between Earth and the Sun, about 150 million kilometers. The Oort cloud represents the outermost frontier of the solar system, stretching toward the nearest stars. Although Voyager has not yet reached this region, it is slowly moving in that direction, drifting deeper into interstellar space year by year. Voyager 2 crossed the heliopause on November 5, 2018, confirming many of Voyager 1's observations but also revealing some differences, which continue to intrigue scientists. Both spacecraft have provided invaluable data about the interstellar medium, cosmic rays, and the galactic magnetic field. They have shown that space beyond the solar system is a dynamic environment, influenced by stellar winds, supernova remnants, and the complex gravitational forces of our galaxy. As the Voyagers journey onward, they continue to remind us of humanity's remarkable reach. They embody the spirit of exploration and the enduring quest to understand our place in the cosmos. The mission has lasted far beyond expectations. Initially planned for just 4 years, it has now spanned more than 4 decades, outliving its creators and inspiring generations. Beyond their scientific contributions, the Voyagers carry a unique cultural artifact, the Golden Record. This phonograph record contains greetings in 55 languages, images of Earth and its lifeforms, natural sounds like whale songs and thunderstorms, and a selection of music from around the world. It is a message in a bottle, a testament to humanity's hope that someday, somewhere, another civilization might find it and learn about us. Today, as Voyager 1 and Voyager 2 continue to travel through the cosmic sea, their power sources are gradually dwindling. Engineers must carefully power down instruments to extend their lives as long as possible. Eventually, the probes will fall silent, their final whispers lost in the vast darkness. Yet their legacy will endure forever, a symbol of human curiosity, resilience, and the relentless desire to push beyond boundaries. In the quiet depths of interstellar space, Voyager silently sails onward, carrying the dreams of Earth with it. It is a time capsule, an ambassador, and a cosmic pioneer. As we look up at the night sky, we can take comfort in knowing that somewhere out there, a small spacecraft is still traveling, still listening, still sending us messages from the edge of forever.